Okay, let's give you guys some practice. So somehow integrate this. So press pause and have a go. Okay, so to do this, we need to complete the square on this. But let me just switch these two around. So that will then give us this. So just switch these two around. And now complete the square on this. So completing the square will then take us to here. I'm expecting you to be able to complete the square. So now we can put this back into here. So this whole thing here will then become this. So complete the square. That will then take us to here. Now create a triangle. Create a triangle in such a way that this thing here will be true. So create a triangle in such a way that this thing here will be true. Well, if you make the hypotenuse to be this thing here, and if you make the adjacent to be this thing here, then the opposite will have no choice but to be this, because you're using Pythagoras here. Remember, Pythagoras says if you get this thing squared, take away this thing squared, and then square root the whole lot. That will then give you the opposite. So notice that this thing here is exactly the same as this thing here. But then from our triangle, we need to be able to extract the dx. So we need to somehow extract the dx. So looking at this here and this, if you look at secant would be hypotenuse over adjacent. Secant would be hypotenuse over adjacent. So now times both sides by half. That will then give us this. So now differentiate both sides. So if you differentiate this, that will then give us this, and then you've got your d theta, and then differentiate this, that will just give you root 6, and then you've got your dx here. So now you can see that we can extract our dx here. So divide both sides by root 6. That will then give us this thing here. So dx is this thing here. So we can put this into the dx, and then this complicated thing here is this complicated thing here. So we can look at tan. So tan theta equals opposite over adjacent. So times both sides by a half. So that will then give us this. So now we can put a half tan into this complicated thing here. So put this whole thing here into the dx. Put a half tan theta into here. Then the whole thing here will then become this. And then now hang on. So now imagine this as being a half times 1 over root 6. So you've got one block here times another block here. So imagine as that. So now you can see that this is exactly the same as this. So these two will cancel out. This thing here is a constant, so you can take it outside here. And then your tan theta will cancel out this tan theta. That will just give you secant. So after all that, it boils down to this. So now it's just a matter of integrating secant theta. And I'm expecting you to know how to integrate this by now. So when you integrate this, if you can't remember this, then look it up. But I'm expecting you to know that when you integrate secant theta, it gives you natural log absolute secant theta plus tan theta. So integrating this whole thing here, that will then give us this thing here. But we don't want the answer in terms of theta. We want it in terms of x. So going back to our diagram earlier, secant theta is this thing here. This is secant here. So secant theta is hypotenuse divided by adjacent. So hang on. So secant theta equals hypotenuse divided by this. So that, well, this thing divided by half is the same as this thing multiplied by 2. So that will then be 2 root 6, and then you've got your x, anything x plus 1 over 2 root 6. So now we can put this thing here into here. That will then give us this thing here. And then tan theta, well, what is tan theta? Tan theta is this thing here. So tan theta equals opposite over adjacent. So this thing divided by this thing is the same as this thing multiplied by 2. So it would be this thing here, 6 x plus 1 over 2 root 6 squared minus a quarter. So now we can put this back into here. That will then give us this. So this, hang on. So this is our final answer. Okay.